Hello there, algebra peoples. Sorry that we are not live and in person, but this is the next best thing since I have other things to do, other places to be, and maybe you do too. Anyways, we'll try to make this as painless and logical as possible. I'm going to show you a second method of how to find the roots. Actually, I guess it's the third method. Remember that the roots of a quadratic equation would be the x-intercepts if we found them on a graph. If we had our equation factored, we would squiggle McWiggle, and the value of our roots are always the opposite sign as our factor, because we were looking for the numbers that make our factors turn into a zero, which means we would have to have the opposite number of what's already there. The opposite of -3 would be +3, so 3 minus 3 is 0. We ran across some issues yesterday that sometimes we couldn't find the factors from the graph, or sometimes we had an equation that did not factor. So today we're going to see another way of how we could find the roots if the roots are not necessarily whole numbers. Okay, so let's first take our example and review what we did yesterday and the day before. So what we did is we got the equation equal to 0, get it equal to 0, get it equal to 0. That's always first. That's already done for us. Woohoo! Next, we would check for a GCF. For this particular example, our GCF will be -16. And I want to factor out the -16, so I end up with a positive x squared. If my x squared was positive to start with, then I would keep it positive. But this is a negative, so I'm going to make it negative. So factoring out the factor of -16 means I will divide each of my original values by -16, leaving me with x squared and then -1. From here, I mentioned that if your GCF is just a number and no variable attached to it, you can divide out that number and then factor what's left if it would factor any more. This happens to factor into x plus 1, x minus 1. And then according to what we've done in the last few days, we will squiggle McWiggle our way down to our roots, setting each factor equal to 0. Add 1 to both sides to get +1 for one of our roots. Subtract 1 from both sides to get -1 for the other root. And that's what we did the last couple of days. We've been practicing some of this stuff, practicing our factoring, practicing our solving equations, and squiggle McWiggle. All right, so our new method is going to be called taking the square root. So the square root is the same thing as the radical. That's our square root symbol. Square root. That means to unsquare a value. So if you did the square root of x squared, it unsquares it back to regular x. In order to do this, we are going to get all the numbers on one side and whatever is squared on the opposite side of the equal sign. So we can first subtract 16 from both sides, leaving us with -16 x squared equals -16. We want the term that's squared to be isolated all by itself. So we are going to then divide by -16 on both sides, leaving us with x squared on the left. -16 divided by -16 is +1. So this is only going to work if I have an x squared and no other x's. Because now, at this point in the problem, what I'm going to do is square root both sides of my equation. I can only do this if I have a single number on one side and the other side is squared. Now, when we square root x squared, that gets us down to x. That's the whole point. That's how we get rid of an exponent of 2, is using the square root. When we do the square root of 1, we have to include the fact that it could be +1, could be -1. Plus and -1 means I have x equals +1 is one of my roots and x equals -1 is one of my roots. That's what the plus minus means. +1 and -1 are my two answers. I have written things like that before for you, but not very often. But here you'll see it. Here you see it come back once again. So again, this square root method only works if I have an x squared term and nothing else, because I can't do this if there's an x involved. And then I have to get the x squared all by itself, and then any numbers, all the numbers go on the opposite side. You cannot square root when it's adding or subtracting. All right, that will not work. It has to be a single number on both sides of the equation. Okay, so letter B here. We need to get the x squared by itself. So our first step is going to be divide away the 4. It doesn't matter that it's a fraction. Once the x squared is alone, the other side is just a number. Then we can square root both sides of our equation. As in the past, the square root and the x squared cancel each other out, getting us just to plain old x. When you do the square root of a fraction, you can take the square root of that fraction and separate the square root of the top from the square root of the bottom. So you can do the square root of 9 and then the square root of 4 and include the positive option and the negative option. I'm going to write it a little bigger for you. Square root of 9 is 3. Square root of 4 is 2. So we have positive or negative 3 over 2. If we wanted to solve this by factoring, because I just put that in the wrong spot. So all this stuff should go, that doesn't matter. If we did this yesterday's way by factoring, we would subtract 9 from both sides. We would factor this as a difference of 2 perfect squares. And then according to the squiggle McWiggle thing that we would do, we would set each one of our factors equal to 0 and solve for x. 2x minus 3 equals 0. And then 2x plus 3 equals 0. To solve each one of those individual equations for x, I would have to add 3 here, leaving me with 2x equals 3. Then I would divide by the 2, and that matches one of my roots of positive 3 over 2. For the other factor, I would subtract the 3, leaving me with 2x equals negative 3, and then divide by the 2, and that is where I would get the root of negative 3 over 2. So both methods lead to the same answers, a positive 3 over 2 and a negative 3 over 2. By factoring, I would have a positive 3 over 2 and a negative 3 over 2. So sometimes you have the choice of which method to use. Sometimes one's better than the other. If you're dealing with numbers that will factor, maybe sometimes factoring will be easier for you. If there is no way that this will factor, if it's not a difference of 2 perfect squares, then we have the square root method. Now, this is very important. Our square root method is used when the b term is missing. What I mean by the b term is in standard form, a quadratic equation is ax squared plus bx plus c. When that b term is missing, which goes back to what I said earlier, as long as there's just an x squared, no other x, When that is missing, that's when we can isolate the squared term, take the square root of both sides, and write down the positive and negative square root. Sometimes when we take the square root, we're going to have to simplify the radical. It just depends on what number we have on the other side of the equal sign. Now, in order to do our square root method, we have to have the square root of one single number and the square root of whatever's squared on opposite sides of the equal sign. That means in example A here, I have to divide by 3 first. 9 divided by 3 is 3. Once the x squared term is all alone, then and only then can I square root both sides. Now the square root of x squared just goes to x. The square root of 3 is a decimal that never ends and never repeats because it is irrational. So I will just leave it as positive or negative radical 3. This would be something that would not factor and would not show nice, neat whole number roots on a graph. So there's no way we would be able to get to these roots by the methods we already know previous to today. Our example B here is very special because instead of individual x squared, we have the whole quantity x minus 5, the whole thing squared. So because what's squared is already isolated, we can jump straight to taking the square root of both sides. The square root of the whole parentheses x minus 5, the square root of that whole thing gets rid of the exponent of 2, leaving us with just the x minus 5. On the other side of the equal sign, the square root of 100 is just 10. This is okay to do because the x minus 5 is all in a parentheses, and the exponent of 2 is on the outside of that parentheses. So our square root cancels out with that exponent, leaving us what was inside the parentheses of x minus 5. Now, of course, we have to solve for x. So we have to add 5 to both sides to get our final answer of x is 15. But we also have to consider that when we did the square root of 100, it could have possibly been negative 10 times negative 10 that created that 100. So that's where we get our second root from. So we're going to add 5 to both sides to cancel out the 5s. But then that means our second possible root is negative 5. There we have our two roots, as we should have because our equation started with an exponent of 2, so we know we should have two roots. One of them came from the square root of 100 being positive 10. The other came from the option where the square root of 100 could have been negative 10. If you're a little confused why we need the plus and minus, let me take you down here for a second. When you square a number, that means to multiply a number times itself. If you had to square a negative number, you would square or multiply that negative number times itself. A negative times a negative turns a positive. Positive times a positive is also positive. Square root, going backwards through this process, asks what number times itself gives you a positive 9. And the answer is unclear because we could do positive 3 times positive 3, but we could also do negative 3 times negative 3. So that is why we do both possible options when taking the square root and solving an equation. Okay, so let's practice. Remember that what we have to do first is get the thing that is squared all by itself. That means we are going to start with dividing by 2. So the 2 cancels out, leaving us with the x plus 4 quantity squared. On my Inspire, or in your brain, you can do 32 divided by 2. Once the squared term is isolated, we can go ahead and square root both sides of our equation. Canceling out the exponent of 2 is why we do the square root in the first place. Taking the square root of 16, we get either positive 4 times positive 4 or negative 4 times negative 4. So we can still use our idea of squiggle McWiggle here, because it's always fun to say squiggle McWiggle, where we have x plus 4 might equal positive 4. The other possibility is x plus 4 would equal the negative 4. That would lead us to two different solutions and our roots. So solve for x. And solve for x. If I gave you this problem a couple days ago, you would go to the calculator, type in your graph, and you would see something like this. One of the roots is at 0, the other one's at -8, and you could still come up with the same two results. Now that works out nice if they're whole numbers. If they weren't whole numbers, if they were irrational numbers, we wouldn't be able to get them from the graph. All right, so let's keep going. We have to subtract the 7 first. If you need to, go ahead and use your calculator. And then we have to divide by the 3. And now, finally, we can square root both sides of our equation. Square rooting both sides is what gets rid of the exponent of 2, leaving us with just the x minus 5. On the right-hand side of our equation, the square root of 9 comes or leads us to either positive 3 or negative 3. And then we can squiggle McWiggle our way through our two possibilities, where x minus 5 might equal positive 3, or the x minus 5 might equal the negative 3, leading us to the two roots or two solutions that we would expect to get. We would expect to get two solutions because our highest exponent in our original equation was a 2. The degree, or the highest exponent, tells you how many roots you should have when you're all done. So go ahead, why don't you pause the video and try E and see what you come up with. If at any time I'm going too fast, feel free to pause the video to catch up. If you think I'm going too slow, you can always try to fast forward a little bit and see how that goes as well. So hopefully you got to the same result as I did. I had to subtract 4 from both sides. Negative 125 minus 5, or divided by negative 5 is 25. Square root of 25 is positive or negative 5. So we do our squiggle McWiggle where 3x minus 1 might equal positive 5, or 3x minus 1 might equal negative 5. I will add 1 to both sides in both instances and then divide by 3 on both sides in both instances, leading to 2 possible roots. Okay, so let's try f. Let's see what happens with this. Add 3 to both sides. Hopefully you're getting the hang of this. 20 is not going to be a perfect square like our other examples. So when we go to take the square root of both sides, we are now going to have to use those simplifying radical skills that you've been practicing on your weekly. Okay, so kind of off to the side, either mentally or literally physically off to the side, we have to simplify the square root of 20. So you need to find what's the largest perfect square that is a factor of 20. If you don't remember how to do that, we go to the calculator, go to our graph, and we hit the tab button. We're trying to find the largest perfect square that multiplies to be 20. So we will do 20 divided by x, almost like we were factoring. And we're going to go to the table of values by Control T. And what you will look for is over here in the light gray column on the right-hand side, what's the first perfect square that's on the y side of your table. 20 is not a perfect square. 10 is not a perfect square. Anything with a decimal, we're not going to use. 5 is not a perfect square. 4 is a perfect square. 4 is the first perfect square that I come to in the y column. So that means 4 will be the largest perfect square that I want to use. So when I write down 4 and 5, because 4 times 5 is 20, which one of those numbers was the perfect square? Can we take the square root of 5, or can we take the square root of 4? The square root of 4 comes out to be a whole number of 2, and the square root of 5 just stays radical 5. So that's what it means to have our answer in simplest form. Now, of course, we're trying to solve this equation for x, so I got to get x alone, so I still have to add the 2 across the equal sign. But this 2 does not have a radical 5 with it, so that goes first. And then I have my plus or minus 2 radical 5. Again, these are roots that we would not be able to factor. These are roots that come from a graph where they're not whole number x-intercepts. So there is no way other than the square root method that we know of right now of how to do this. Okay, so now off you go and practice by turning the page and working on the homework set. And then when you're done with that, you can work on your weekly if you haven't done that yet. Or you can just be nice and be quiet. And I will see you soon. Well done today. Feel free to go back and rewind anything you need. And take care of yourself.